What neurotransmitters does olanzapine affect? Have you ever wondered how certain medications work in the brain? Today, we will discuss the neurotransmitters affected by olanzapine, especially in the context of schizophrenia. Understanding this can help us grasp how treatments can alleviate symptoms. Olanzapine primarily targets two key neurotransmitters, dopamine and serotonin. These chemicals play vital roles in regulating mood, behavior, and thought processes. In schizophrenia, imbalances in these neurotransmitters can lead to symptoms like hallucinations and delusions. Let's start with dopamine. Olanzapine acts as an antagonist at dopamine D2 receptors. This means it blocks these receptors, which helps reduce the overactivity of dopamine pathways. This overactivity is often linked to positive symptoms of schizophrenia, such as hallucinations and delusions. When we look at the dosage, the degree of D2 receptor occupancy by olanzapine typically ranges from about 43% to 80% at common clinical doses, which are usually between 10 milligrams and 20 milligrams per day. It is important to note that higher occupancy levels above 80% may increase the risk of side effects, such as movement disorders and elevated prolactin levels. Therefore, the goal is to maintain occupancy below this threshold to balance effectiveness with side effects. Now, let's turn to serotonin. Olanzapine is a potent antagonist of serotonin 5-HT2 receptors, particularly the 5-HT2A subtype. It achieves near-complete blockade of these receptors even at relatively low doses, around 5 milligrams per day. This action on serotonin receptors is believed to contribute to olanzapine's effectiveness in treating schizophrenia by modulating neurotransmission beyond just dopamine pathways. What sets olanzapine apart from older antipsychotics is its stronger affinity for serotonin receptors compared to dopamine receptors. This unique characteristic may help reduce some side effects, like motor symptoms, which are often associated with other treatments. In addition to dopamine and serotonin, olanzapine interacts with other neurotransmitter systems, including histamine, muscarinic acetylcholine, and adrenergic receptors. These interactions can contribute to side effects such as sedation and metabolic changes. However, the primary therapeutic effects in schizophrenia are linked to the modulation of dopamine and serotonin receptors. In summary, olanzapine's antipsychotic effects arise mainly from its combined blockade of dopamine D2 and serotonin 5-HT2 receptors. This dual action helps alleviate psychotic symptoms while aiming to minimize motor side effects. Understanding these neurotransmitter effects can provide a clearer picture of how olanzapine works in managing schizophrenia symptoms.